So today we're going to go over Unit 10, which is stoichiometry. The definition for stoichiometry is the quantitative study of reactants and products in a chemical reaction. Stoichiometry is a fancy word for basically what we're doing is we're going to be giving, quantitative is numbers. We're going to be giving a numerical value to how much product we're going to be able to produce in a chemical reaction. So before actually doing an experiment, we can do some calculations, stoichiometry calculations, and predict how much product we should be making. This word, stoichiometry, it sounds hard, but it's really not. It comes from the Greek word, so stoichion means elements, metron means to measure. So stoichiometry, what it stands for is the measurement of elements. We're going to be measuring how much product we can produce in a chemical reaction. So stoichiometry is a calculation that involves the mass, the relationship of the mass between the reactant and the product in a balanced chemical reaction. Remember that the reactants, those are your ingredients. What's in front of the arrow. The products is whatever we produce in a chemical reaction, and that's after the arrow. It is very important that for these type of calculations, our chemical reaction has to be balanced. So something that we're going to need for stoichiometry is something called the mole ratio. So the mole ratio is going to be a ratio of moles. Remember that moles tells us how many of each compound we have. So mole ratio is a conversion factor that relates the amount in moles of any two substances in a balanced chemical equation. Again, remembering that conversion factor is a fraction in which the top equals the bottom, and we're going to use mole ratios in order to go from moles of one element to moles of another element or compound in a balanced chemical equation. Okay? Mole ratio is very simple. It actually comes from the coefficient of your balanced chemical equation. Remember that coefficient, that is a number that we put, the big number that we put in front of a compound in order to balance the chemical equation, in order to have the same amount of elements on both sides of the arrow. Okay, so if we look at this example about making s'mores, let me go down. So let's say we were making s'mores, right? And I were to write a chemical reaction for s'mores making. I would have 2 graham cracker, GC is graham cracker, plus 1 marshmallow, big M for marshmallow, and 4 chocolate pieces, CP for chocolate pieces. So if I mix all these together, I make this product, which is a s'more, which a s'more has GC and a subscript of 2 because I have 2 graham crackers in one s'more. M, marshmallow, with no subscript behind it because I only need 1. And if I need 1, I don't need a subscript. And then chocolate pieces, a subscript of 4 because in each s'more, I'm going to have 4 chocolate pieces, 1 marshmallow, 2 graham crackers for every 1 s'more. So these numbers here, my coefficient tells, I could get the mole ratio from those coefficients. So if I look, my coefficient tells me that I'm going to need 2 moles of graham cracker for every 1 mole of marshmallows, for every 4 moles of chocolate pieces, for every 1 mole of s'mores. Okay, now let's say if I have a question that says, how many s'mores can you make if you have 24 graham crackers? So if I had 24 graham crackers, how many s'mores can I make? Well, for that, I would have to look at my balanced chemical equation and see how many graham crackers do I need for every s'more. And by looking at this, I see that I need 2 graham crackers for every 1 s'more. Well, there's a very simple calculation in which I could just divide 24 divided by 2 to give me 12 more. S'mores. But let's say if I did it the way we're going to do it in chemistry, is I would start with what was given to me, 24 graham crackers. I start with 24 graham crackers. Then I'm going to use this mole ratio. Okay, that tells me how many moles of one compound to another compound I need. So I need 2 moles of graham cracker. I'm going to write graham cracker in the bottom so that graham crackers and graham crackers cancel out. Here I should actually have moles. So I need 2 moles of graham crackers for every 1 mole of s'mores. So in the top, I'm going to write 1 mole of, instead of writing this compound, I'm just going to write s'mores. Okay? Like this, when I divide 24 divided by 2, it tells me that I'm going to be able to make 12 moles or 12 s'mores. Okay, that's my final answer. So I use this mole ratio in order to go from moles of one element or compound to moles of another compound. Okay, now we're going to do another example, but using an actual chemical equation. Okay, so here we're going to work on our first stoichiometry problem. And this problem says, determine the amount of moles of aluminum that can be produced from 13 moles of aluminum oxide. Okay, and we're also given a balanced chemical equation that, remember, based on the coefficient tells us that for every 2 moles of aluminum oxide that decomposes, that is going to form 4 moles of aluminum and 3 moles of oxygen. So for every 2 moles of aluminum oxide, there is 4 moles of aluminum and 3 moles of oxygen. So this question is asking us that if we have 13 moles of aluminum oxide, which is Al2O3, they're asking us how many moles of aluminum is there. Okay, so they're giving us the information in moles, and they want us to find the moles of another element. So they're giving us the information of moles of aluminum oxide, and they're asking us how many moles, how many aluminum atoms can we make. So the first thing you're going to do here is you're going to write what is given to you. So I'm going to start with 13 moles of aluminum oxide. Okay, I know that we like to take shortcuts, but it is imperative that for these type of problems, we write the number, the unit, and the element or compound we're talking about, especially since we're going to be going from one compound to another. So we're going to have 2 compounds to worry about. So take your time, take the trouble, write everything down. Okay? So the only way, they're giving us information from one compound, and they're asking us information about another compound. The only way to go from one compound to another is by using what we just talked about, the mole ratio. Okay? Using the mole ratio is the only way that you could go from one compound to another compound in a balanced chemical equation. So we're going to be looking at only aluminum oxide and aluminum. So we're going to be looking at this ratio of 2 to 4. Now the next step is to decide who goes in the bottom and who goes in the top. Okay? Remember that when you write it down, this is going to help you determine is 2 moles of aluminum oxide or 4 moles of aluminum going to go in the bottom. So who's going to go in the bottom? 2 moles of aluminum oxide. 2 moles of aluminum oxide. The reason that we want 2 moles of aluminum oxide in the bottom is so the moles of aluminum oxide and moles of aluminum oxide cancel each other out. In the top of this mole ratio, since the question is asking us about aluminum, we're going to put 4 moles of aluminum. Okay, like this, like I said before, moles of aluminum oxide and moles of aluminum oxide cancel each other out. And I am done, okay? Because as you could tell, as you could see, the only unit that's not crossed out is moles of aluminum And that's what the question is asking us about. Excuse me. So now what I'm going to do in my calculator is I am going to get 13, multiply that by 4, divided by 2, and it gives me 26.0 moles of aluminum. And that is my final answer. So now my final step is I'm going to multiply everything on top, divide by the bottom. So 13 times 4 divided by 2, and that equals 26. Remember that my answer needs 3 parts: the number from the calculator, the unit, and the element that we're talking about. So 26 moles of aluminum. Okay, and that's my final answer. I am done. Okay, so now using the same chemical equation from before, we're going to do another example that's a little bit different. So this one says, determine the amount of moles of oxygen gas that can be produced from 13 moles of aluminum oxide. So again, we have 13 moles of aluminum oxide. That is the given. But now they're asking us to find the moles of oxygen. Okay? So for this type of problem, again, they're giving us 13 moles of aluminum oxide, and they want us to find moles of oxygen. They're giving us the information in mole. They want us to find moles of another compound. So this would be a mole to mole problem. These type of problems are the easiest because it's just a one-step process. So again, we always start with what's given to us. So we're going to start with the amount given. That's going to be in moles. Then we're going to use mole ratio. Because remember, the mole ratio is the only way that we could go from one element to another. And then we're going to calculate to find our answers in moles. So let's do this problem. So to start this problem, again, we're going to start with what was given to us. 13 moles of aluminum oxide. I'm going to take my time, take the trouble, write the unit and the compound that we're talking about. Now, since we are already in moles, we can use the mole ratio. So my next step is going to be to use the mole ratio. I'm going to use the mole ratio now because I am already in moles. Well, when I'm in moles, I could use a mole ratio. So the mole ratio, again, remember, it comes from my balanced chemical equation. Since here the information is given about aluminum oxide and they're asking about oxygen, I'm going to use the 2 and the 3. Now I have to decide which one goes on top and which one goes on the bottom again. And that is based on what I start with. So since I started with moles of aluminum oxide, I'm going to write moles of aluminum oxide in the bottom. So 2 moles of aluminum oxide in the bottom so they cancel each other out. And in the top, I'm going to write the moles of oxygen based on my balanced chemical equation. So based on my coefficient, 3 moles of oxygen. Remember, like this, the moles of aluminum oxide cancel out. And now I am done because the only unit that is left uncrossed is moles of oxygen, and that is what the question is asking about, moles of oxygen. So now what I'm going to do is I'm going to get my calculator, get 13, multiply by 3. Remember that everything on top you multiply, and everything in the bottom you divide. Divide by 2, and that gives me 19.5, the number, the unit, and the element that we're talking about, moles of oxygen. Okay, and check that your answer and the unit that's not crossover is what the question is asking you. It's asking you for moles of oxygen. You're giving moles of oxygen. Okay, and that is it. Okay, now for example number 3, it says how many moles of lithium how many moles of lithium hydroxide are required to react with 20 moles of carbon dioxide? So remember, the first thing you want to do is you want to read your question, highlight, underline, circle, whatever, what they're asking you to find and what they're giving you. I also have my balanced chemical equation on here. I'm going to go ahead and I'm also going to write what is given to me and when they're asking me under my balanced chemical equation. Okay, so they're giving me 20 moles of carbon dioxide. So under carbon dioxide, I'm going to write 20 moles. Oops, and they're asking for lithium hydroxide. Lithium hydroxide is this one, lithium hydroxide. So this one, they're asking question mark, for moles. Okay, so in this question, they are giving me the information in moles, and they're asking me to go to moles. So this is a moles to mole question. Okay, and remember that this one is the simplest one. Today we're gonna go over 4 different types of questions that you can be asked. But this one is the simplest, moles to moles. In this one, we're only gonna use one step, and that is using the mole ratio. Remember, the first thing you always do is you start with what was given to you. 20 moles of carbon dioxide. 20 moles of CO2. Excuse me. Then, since we're already in moles, the next step is going to be to use the mole ratio. Remember, again, that the mole ratio comes from your balanced chemical equation. So we're going to go to the balanced chemical equation and look at the coefficients. So since there's no number here, that means that we have a 1. Okay, so we have 1 mole of carbon dioxide for every 2 moles of lithium hydroxide. Our next question is, who goes on the top and who goes on the bottom in this mole ratio? We're going to look at the unit and the compound that we started talking about, so that was given to us. Moles of carbon dioxide, we have it here in the top. That means that in this ratio, we want to write moles of carbon dioxide in the bottom. So in the bottom, we're going to write 1 because there's a coefficient of 1 here. If there's no coefficient, that means that we have 1 mole of CO2. And in the top, we're going to write the coefficient of the compound that we're being asked about. In this case, lithium hydroxide, there's a 2 in front of it. So that means that we have 2 moles of lithium hydroxide. The reason that we wrote moles of carbon dioxide in the bottom is so that, remember, they cancel each other out. And now, am I done? Let me see. The question is asking me for moles of lithium hydroxide. Right now, the only unit that's not crossed out is moles of lithium hydroxide. So yes, I am done. My next step is to get my calculator, multiply everything that's on top, and divide by the bottom. In this case, since there's a 1 in the bottom, I don't really have to divide by 1. So all I would do is multiply 20 times 2, and that gives me 40 moles of lithium hydroxide. And that is my final answer. I am done. Okay, they're asking us for moles of lithium hydroxide. I'm giving them moles of lithium hydroxide. And that's it. So like I said before, in stoichiometry, there's 4 different types of problems. We've already gone through the first type, which was mole to mole. Now we're going to go in the second type of problem that we can have, which is moles to grams. So here we're going to be converting from grams of one element or compound to the mass of another element or compound in a balanced chemical equation. Okay, so let's see the steps. The general steps for these type of equations is we're always going to start with what's given to us. In this case, they're going to give us the information in moles. So we're going to start with information given, which is going to be in moles. When we're in moles, the only way we could go from one compound to another is by using the mole ratio. But in order to use a mole ratio, we have to be in moles. And here we're already in moles. So my next step is going to be to use a mole ratio, which is going to be moles of unknown over moles of given. Given in the bottom so that it counts out with the moles here of the given. Then the moles of the unknown in the top. But in this question, they're asking us for the mass of the unknown, of whatever they're asking us about. So once we're in moles, we're going to use the molar mass of that compound. And we're going to be multiplying by the molar mass in order to get the mass. Okay? Let's do a real example now. So down here, example 4, we have, what is the mass of glucose that is produced when 3 moles of water reacts with carbon dioxide? Okay, so again, the first thing I'm going to do is I'm going to highlight, circle what's given to me in the problem. So what is the mass of glucose? That's what's being asked. So down here in glucose, I'm going to box in glucose and question mark, mass, which remember mass and grams are the same thing. So they're asking me for the grams that is produced when 3 moles of water. Whenever I have 3 moles of water, water is right here. So I'm going to box in water in my chemical equation and put that I have 3 moles. Okay, the reason that I like to do it like this is so that I could visually see what they're giving me, what they're asking me for, and I could quickly look at the coefficient to find that mole ratio. Okay, because in all of these problems, we're always going to be using mole ratio. So again, the first thing that I always do is that I start with what was given to me. 3 moles of water. So I'm going to start with 3 moles of H2O. I'm going to take my time. I'm going to take my trouble, write everything down. Okay, so now since I am already in moles, my next step is going to be to use a mole ratio so that I could make that jump from one compound to another. The only way I can make this jump is by using this mole ratio. Okay, since I started with water, I want the moles of water in the bottom. And remember that comes from my coefficient. So 6 moles of water in the bottom. And in the top, if there's no coefficient in front of the compound, that means there's 1 mole. Not 0, but 1. C6H12O6. I know it's tedious, but write everything down. So, and then once you do a step, go ahead and start canceling things out. So moles of H2O and moles of H2O get canceled. Okay, now I am left with moles of glucose. But the question is not asking for moles of glucose. They're asking me for the mass, for the grams of glucose. Is there any way that we know, that we've learned about, how can we go from moles of a compound to grams of that compound? How can we do that? If you guys said molar mass, ding, 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 you are correct. Molar mass. And where does molar mass come from? Excuse me, I need to get my periodic table. If you said from the periodic table, you are correct again. So you're going to need your periodic table. And now I need to find the total mass of all of these elements. So I'm going to do it down here, okay? So I have carbon, hydrogen, and oxygen. I'm going to count how many elements I have in the compound. So carbon, I have 6. Hydrogen, I have 12. And oxygen, I have 6. Okay, now I'm going to multiply how many of each element I have times their mass according to the periodic table. Excuse me. So carbon has a mass of 12.01. So I'm going to do 6 times 12.01 grams per mole. Remember that the molar mass, the unit is grams per mole. When I multiply 6 times 12.01, it gives me 72.0 grams per mole. Okay, now I have 12 hydrogens. Each hydrogen Again, if I look at the periodic table, it has a mass of 1.01 grams per mole. So if I do 12 times 1.01, I get 12.12 grams per mole. And oxygen, I have 6 of them. Each oxygen has a mass of 16 grams per mole. When I multiply, it gives me 96.00 grams per mole. Okay, so in order to find the molar mass, the mass of the whole compound, I need to now add all of these separate parts so that it gives me that glucose has a molar mass of 180.12 grams per mole. Okay, so now I'm going to put this number. This tells me how many grams 1 mole of glucose weighs. Since I have moles here in the top, moles of glucose, in the bottom, I'm going to put 1 mole of C6H12O6. So in 1 mole of glucose, that has a mass of 180.12 grams of C6H12O6. So the molar mass that comes from the periodic table tells us how many grams 1 mole of that compound weighs. Again, I put the moles in the bottom, so the moles of glucose and moles of glucose cancel each other out. Take the time, take the trouble, and after each step, cancel your units so that you do not get confused. Now, am I done? I do not know. Let me check. What is the only unit that's not crossed out? Grams of C6H12O2. What did I write here? 12.6. Sorry about that. And the question is asking me for grams of glucose. Grams of glucose. I am done. Okay, since the only unit that's not crossed out is grams of glucose, and that's what the question is asking me, I am done. So now my next step is to get my calculator. Okay, everything that's on top, and I'm going to multiply. Anything in the bottom, I'm going to divide. So I'm going to do 3 divided by 6 times 180, all in one step in my calculator. And that's going to give me 90.1 grams of C6H12O6. And that is my final answer. Okay, and again, remember this was for moles to grams. The information was given to me in moles. They were asking about grams of another element. So I first have to use a mole ratio, then the molar mass. And I am done. The third type of problem in stoichiometry is the conversion of mass to amount of moles. So here we're going to go from grams to moles. In the previous problem, we went from moles to grams. Here, the information is going to be given to us in grams of one element, and we're going to have to find out how many moles of another element we're going to have. Okay, so the general steps for these type of problems are the following. So we're going to start with the mass given. Remember that we always start with whatever the problem gives us. In this case, going to be in grams. Since we're not in moles, we cannot use a mole ratio now. Okay, the first thing we need to do is convert this grams into moles so then we can use a mole ratio to go from one element to the next. So since the information is given to us in grams, we're going to use the molar mass of the given, divide by it, so the grams cancel out, be left in moles of given. Okay, once we're in moles, now we could use a mole ratio. Comes from the coefficient. We put the moles of the given in the bottom, moles of the unknown in the top, the moles of the given cancel out, and bada boom, bada bam, we have our final answer. Okay, so now let's do a real example. Example 5 that says how many moles of NO. So they're asking us for moles of NO. So in my balanced chemical equation, I'm gonna box it in NO, question mark, question mark, question mark, moles are formed when 824 grams of NH3 react with excess oxygen. So they're giving us information about NH3, so I'm going to box in NH3 and put 824 grams. Okay? So they're giving us the information in grams, and they're asking us for the moles of another compound. So the first thing I always do, remember, is I'm going to start by writing what was given to us in the problem. 824 grams, and go ahead and also write the compound, NH3. This is not the unit that you want to be lazy in. You want to take your time, take the trouble, write everything out, cancel out the units when you need to. This will really save you. And by writing everything out, your brain should already know what to do just by looking at what you have, okay? So remember, in every problem, I'm going to have to use the mole ratio, right? Because the mole ratio is the only way that I could jump from one compound to another compound by looking at these coefficients, by looking at the ratio of how many of one element to the other element I need. But in order for me to use a mole ratio, I need to be in moles. And right now, I am not in moles. Right now, I am in grams. So I need to get rid of the grams. And remember that every time you see grams, you need to use molar mass, okay? Because the molar mass gives you how many grams are in 1 mole. Molar mass. So I'm going to have to use the molar mass of NH3 in order to go from grams to moles. So I'm going to go here. Now I'm going to find the mass, the molar mass of NH3. So I have N and I have hydrogen. I have 1 nitrogen and 3 hydrogen. I'm going to multiply them times their mass according to the periodic table. So I have nitrogen. Nitrogen has a mass of 14.01. So 1 times 14.01 equals 14.01 grams per mole. Okay, I did not have to do this step, but I'm just doing it to be consistent. NH3 has 3 hydrogen. So I'm going to look at the periodic table. Does it fit? Yes. Hydrogen has a mass of 1.01. 1.01 grams per mole times 3 is 3.03 grams per mole. To find the mass of the whole compound, I add it, and it gives me 17.04 grams per mole. Remember that the molar mass tells you how many grams are in 1 mole of that compound. So now up here, I'm going to go back to my problem. Since I have grams in the top, okay, in the bottom, I want to have grams of NH3. So this number, this mass that I just found, I'm going to write it in the bottom. 17.04 grams of NH3 for every 1 mole of NH3. Again, the reason that I do this is so grams and grams cancel each other out. So after each step, cross out the units, they cancel out. Okay, now I am left in moles. You see that the grams get canceled out. I am left in moles. Now I could use my mole ratio. Because since I am in moles, now I could use the coefficient from my balanced chemical equation to go from 1 unit to go from NH3 to NO. Okay, so in this case, I have 4 and 4. So it doesn't matter, they're both the same. But in the bottom, do I want the moles of NH3 or the moles of NO? In the bottom, I want the moles of NH3. Okay, remember the reason that I want this is so the moles of NH3 and moles of NH3 cancel out. And then in the top, I want the moles of NO, which based on the equation is 4 moles of NO. Capital O. Now, am I done? I don't know. Let's check. What is the only unit that is not crossed out? Moles of NO. What is the question asking me? is asking me for moles of NO. So am I done? Yes, I am done. So now what I'm going to do is I'm going to get my calculator. Everything else in the top I multiply, in the bottom I divide. So I'm going to do 824 divided by 17.04 times 4 divided by 4. I'm going to do everything in the same step because my calculator is smart. It can do what it needs to do. It could do this math. So my calculator gives me 48.4. Remember that my answer needs units, moles of NO. Since that was the only thing that was not crossed out, that is my answer. So my final answer is 48.4 moles of nitrogen monoxide, NO. And I am done. So just a little recap. This question was going from grams to moles. Okay, so in order to go from grams to moles, first have to use the molar mass. Sorry that I keep going back and forth. Let me like this. So in order to go from grams to moles, first I'm going to use the molar mass. Then I'm going to use the mole ratio. First I'm going to use the molar mass in order to cancel out the grams and get the moles. Then once I'm in moles, I could use the mole ratio and I have my answer. So the last type of problem that we're going to talk about is conversion of mass to mass. Okay, so here they're going to give us the information in grams and they're going to ask us for the grams of another compound. This is the longest because we're going to have to do three different steps. Okay, so first you're going to start with what was given to you in the problem, which is going to be in grams, mass of the given. Remember that in order to go from one compound to another, you need to use the mole ratio. But in order to use a mole ratio, you need to be in moles. So the first thing that I'm going to do is I'm going to use the molar mass of the given, divide by it, so the grams of the given get cancel out, and I'm left in moles of given. Then, once I'm in moles, I'm going to be using my mole ratio, moles of given, moles of unknown. Then my final step, since they're going to be asking for grams, is to use the molar mass of the unknown. Okay, and in this case, I'm going to be multiplying by it because I'm going to have moles in the top, I want moles in the bottom, so they cancel out, mass in the top. Okay, and then that gives me my answer of my unknown in grams. So it is a lot of steps. You will see that it's going to take the longest time to do, but again, it's not hard. Same steps that we've been doing, just doing them all together. Okay, last unit we were going from grams to moles, so we were just doing one step. Now we're combining more than one step and introducing this new topic of the mole ratio. Okay, so the last example number 6. How many grams of SNF2, so SNF2, question mark, grams, so asking us for grams, are produced from the reaction of 30 grams of HF? 30 grams of HF, 30.0 grams. So here, they're giving us the information of grams. They're asking us to find grams. So it's a gram to gram type of question. That's the longest one. That's the one that we're going to have to use 3 different steps. Okay? So like everything, we're going to start with what was given to us first. So I'm going to start with 30 grams of HF. Remember to take time, take the trouble, write everything down. Okay? So my next step, I cannot, remember, I'm always going to have to use a mole ratio, but right now I cannot use a mole ratio because I'm not in moles, I'm in grams. So I need to go from grams of HF to moles of HF. And the only way that I could do that is by using the molar mass. Okay, so I'm going to find out the molar mass of HF. So I have 1H, which has a mass of 1.01. Remember, you go to the periodic table, 1.01. I have F. I only have one of them. So I'm going to go to the periodic table, look for fluorine, and the mass is 19.00. both are grams per mole. To find the overall mass, I'm going to add these two numbers, and it gives me 20.01 grams per mole. Okay, so this tells me how many grams are in 1 mole of HF. So now I'm going to bring this number up here. Do I write it in the top or do I write it in the bottom? That is the question of the century. And I'm going to write it in the bottom. Okay, the reason that I want to write it in the bottom is because I have 20.01 grams of HF for every 1 mole of HF. I write it in the bottom so that grams of HF and grams cancel each other out, leaving me in moles. Which that's what I want, because my next step, now that I'm in moles, is to use the famous molar or mole ratio, or molar ratio, same thing. Okay, the mole ratio, remember, I get it from my balanced chemical equation. According to my balanced chemical equation, I need 2 moles of HF for every 1 mole of SnF2, tin fluoride. So here, who do I write in the top? Who do I write in the bottom? Since I have moles of HF here on top, in the bottom, I want to write moles of HF. I want to write 2 moles of HF. And in the top of my mole ratio, I'm going to write 1 mole of tin 2 fluoride. Remember that if there's no coefficient, that does not mean 0, that means 1. And the reason that I chose to write it like this is so the moles of HF cancel each other out. Again, I know I've said it 20 times today, but take your time, take the trouble, write everything out, and after each step, I don't want you to take out your calculator and calculate anything. What I want you to do is to cross out the units that have been canceled. Okay, I know it seems annoying and long, but do it, please. Okay, now, are we done? I don't know. Let me check. Right now, the only unit that's not crossed out is moles of SnF2. Is the question asking me for moles? No, it's asking me for grams. So I am not done. I still need to do one more step. How can I go from moles of SnF2 to grams? I would have to use the molar mass of tin 2 fluoride. Okay, so I would have to find the molar mass of SnF2. So I have tin, I have 1 of them, and fluorine, I have 2 of them. So I'm going to go to my periodic table, look for tin, and the mass of tin is 118.71. 0.71 multiplied by 1 is 118.71 grams per mole. Fluorine has a mass of 19 grams per mole. Multiply that by 2, it's 38.00 grams per mole. To find out the mass of the whole thing, of the whole compound, I'm going to add the mass of both elements, and that gives me 156.71 grams per mole. So now I'm going to get this number, okay, and I'm going to bring it up here. Now, I'm going to look at the unit that I have here on cross. I have moles of tin 2 fluoride. So in the bottom of my next step, do I want to write moles of tin 2 fluoride or do I want to write grams of tin 2 fluoride? I want to write moles. So in 1 mole of SnF2, there are 156.71 grams of SnF2. Now I'm going to take my time one more time and cross out those units. Moles of SnF2, goodbye. Now the only unit that's left is grams of SnF2, okay? The question is asking me for grams. I'm giving them gram, so I am finally finally done. Now my last step is to take out my calculator. Okay, I left my calculator in the classroom, so we're gonna improvise. We're gonna use our telephones. We're gonna use our cell phones. A simple calculator will do here. Okay, anything that's on top I'm gonna multiply, anything in the bottom I am going to divide by. So I'm gonna start with my number 30, divide by 20.0, restart 30, that's why I hate this calculator, divide by 20.01. Here we're again dividing by 2, so I'm just going to do divide by 2. This number's in the top, so times 156.71. And my answer is 117.473763. I am not going to write all of those numbers since my original number from the question had 4 sig figs. I'm going to round my answer to also have 4 sig figs. So I'm going to write 117 point, one significant figure, 2, 3, 4. So I'm going to round to this 4. Since 7 is bigger than 5, I'm going to round to 5. Okay, that's not my final answer. I need grams, SNF2. Now that is my final answer, and I am done. Okay, so just a little recap. The information was given to me in grams. They were asking me for grams of another compound. This type of problem is going to be the longest because I need to do 3 different steps. I first need to divide by the molar mass of the given, then use the mole ratio, then multiply by the molar mass of the unknown. You do not need to memorize when to divide and when to multiply. If you let the unit tell you what to do, what to write in the bottom for your next step, that is going to save you. You do not need to memorize when to divide or when to memorize. Let the unit tell you what to do. Do you have to divide? Do I have to multiply? And that is all going to be based on you taking your time and writing everything out, the number, the unit, the chemical, the element, and seeing, okay, if I have grams of HF on the top, that means that in the bottom, my next step, I need to have grams of HF. Okay, and the only way that I could get that is by using the molar mass. Okay, that left me with moles of HF in the top. I need to get rid of that. And the only way to get rid of that and jump to another compound is by using the molar ratio and writing them and having the moles of HF in the bottom. That leaves me moles of SNF2. Okay, great. The question isn't asking me about moles, though, it's asking me about grams. So how in the world can I go from moles to grams? Using the molar mass and putting moles in the bottom. Therefore, I'm going to be multiplying by this. Okay, so let the units help you and guide you on every step. You do not need to memorize anything. The only thing you need to memorize is a molar mass is we need to go from grams to moles or moles to grams. And the mole ratio, you're always going to use it, but you need to be in moles in order to use it. Okay, that is it for today. Thank you. We're done.